Yo, what's up? Welcome back to the channel. Okay, so I get this question asked quite a lot. How do you determine if a wall is load bearing? This video is going to break it down in general terms and give you a general explanation of how you can determine if a wall is load bearing. We're gonna walk through basic structure and how to look for separate items within the structure to then back it out and determine if a wall is load bearing. We're not gonna get into real specifics on types of structure, structural elements, types of load. I'm not gonna get it really complicated. This is a simple version, okay? So the DIYer, maybe the realtor, whatever it is you're looking for, just having a basic idea of what to look for. This doesn't give you a full description of every single time how to determine if a wall is load bearing, because in every instance, before a project is started, before you give a final explanation, or if you do it on your own, you want to make sure that you have a structural engineer come and evaluate what you're trying to do, whether you're removing a wall for a renovation, whether you're trying to determine if something can happen within a house, if you're a realtor, determine if it's a buy or sell, or as a flipper, whatever it is. Make sure you get a structural engineer involved and an architect to set some plans and pull permits before you do day one start the job. But this will give you a starting point to understand basic structure and what you're looking for, and it won't be over your head, I promise. So with that said, let's start at the bottom. Okay, so you always want to come down to the lowest end of the structure, and I'll make sure I don't fall down these stairs. What you want to do is start at the very, very lowest point of any structure and determine where the idea of the, oh fuck, I fucked it up. Okay, so it's really important to get to the lowest point of the structure to find the bearing beams. And that's for any home built at any time. You're gonna have a beam, a girder beam, steel I-beams, whatever it is, depending on the construction. You gotta get to the lowest point, which means it could be a crawl space. If it's slab on grade, then you're starting on the main floor. If you have a basement, great, you can get down there and take a look at it. So we're down here in the basement of this home. And if you can see behind me, and I'll just wheel around, this is our main I-beam for the house, okay? We've got our lolly columns here that are carrying the beam from this point all the way down onto, you can see this cutout right here, that's actually a footing. And that footing actually goes down a specific distance based on structural engineer requirements and soil content, all that stuff. That takes the load down into bearing soil. So that's the lowest point of structure that we have in this particular home, okay? And so for this construction, you can see we have a lolly column here, down there, and then we have the beam bearing on the stem wall, which is concrete, right, back here, and that wall carries down to a footing that's under this slab that spans all the way across to the next corner, to the next corner, next corner. These are spread footings. So this construction is actually spread footing and stem wall. There's all kinds of different types of foundations. We're not gonna get in any of that in this particular video, but I wanted to show you how you start from the furthest point down. So without getting too wordy, here's another I-beam that we have here carrying onto that stem wall. And if you can see, starting basically, these I-beams sit here. We have the floor joists that run perpendicular, and I'll walk it over here too. You see the floor joists run perpendicular to this I-beam, okay? So starting from that point, anything that's sitting above this I-beam in a horizontal direction would potentially be a load-bearing wall. So if we've got an I-beam running this way and floor joists running perpendicular to it, because obviously it's laying load here, okay? This I-beam is picking up the load for all of these floor joists that span across that holds up the first floor. So potentially, and in general terms, anything running perpendicular to those floor joists is going to be load bearing, okay? So now that you have which direction the joists are going and the location of the main I-beam of the house, you can then walk up into the main floor and locate not only the beam location, but also understand which direction the floor joists are going. And so if you're looking at any wall that's running perpendicular to that, that's potentially a load-bearing wall. Okay, so now we're up on the main floor, and I'm gonna point one thing out so you have potential direction and understanding for this video. If you see the floorboard all these floorboards running this way, these planks are running this direction, and you can see if I run back to the wall, okay, this wall is running perpendicular to those floor planks. Now, the direction of our floor joists from downstairs is going this way, okay? So the planks on this floor are running perpendicular to the floor joists, which are running this way, meaning our beam, our main beam that was down there, is running the direction of these floor joists, just for an easy reference, okay? So if the beam is running this direction, and this is running this direction, this wall is running this direction with the floor joists, this is running parallel to the floor joists and perpendicular to the I-beam in the basement. So what that means is this wall is running parallel to the floor joist, not perpendicular. So in theory, this wall probably is not load bearing, okay, in a general sense. Now, obviously any exterior wall within the structure is going to always be load bearing because it's picking up the very end of the structure of the home. So you can't just remove an exterior wall, which should be pretty common sense, but I just want to make sure that's clarified. But in a general sense, if we wanted to open up this wall, open up this a little bit more, it's not necessarily load bearing. Now, again, you want to assess this based on how the structure is stacked above, what type of roof system's in place, etc. I'm not going to get into any of that because I don't want to go over anybody's head or get it too complicated, but we're talking about general sense. Make sure you ask a structural engineer before you get started with any of that work. But in general terms, because this is running parallel to floor joists and perpendicular, it's running perpendicular to the I-beam, it's not load bearing. All right, so now that you've seen like kind of that real life example of me walking through the actual home, showing you what things look like, before I jump in and show you this really simply drawn up explanation of structure, you can kind of visualize, so to speak, on what I'm going to describe next, which is kind of just understanding basic structural integrity of how things work. And if you think about it from a gravity standpoint, where gravity is just constantly just pulling down on things and pushing down on things, right? From the top down, it has to be supported, otherwise it's going to give out, right? So we have to have things designed in a way that would carry a design type of load, which is called. So we're talking about load, and there's different kinds of load. We're not going to get into all those different aspects of structure right now, but we're just talking about how you're determining a load-bearing wall and what the wall is doing. It's just supporting weight, it's just supporting what's called dead and live loads, which is two different components. The dead loads are all the materials being held up, the roof materials, the lumber, everything there besides people, living things, live load, is calculated within the equation that a structural engineer has to design, all right? So simply put, you have all the dead load of all the materials of the structure being supported, and then people standing in the home and walking around and living in the home have to be supported as well. So those two calculations have to go hand in hand for the structural engineer to allocate what types of materials, what size it needs to be, where these posts and beams and lolly columns, as you saw earlier, need to be in position for each other. And in, again, a simple general aspect, you have those components all working together to support every aspect of the structure and everything within it, okay? So starting from the top down, you have a roof truss system, which is an engineered roofing design, or you have what's called a rafter, which is just a stacked dimensional lumber, okay, with a nominal size that is hand framed on site. There's, another way to design a roof. Again, I'm not going to get into any of that stuff. Don't worry about that. But basically what we have is from the top down, we have the roof, then we have something supporting the roof, and then we have our second floor structure in this example. So anything that's running parallel to the floor joists is going to be most likely non-load bearing. Anything running perpendicular to those floor joists, right, the direction that beam in the basement was running, is most likely going to be load bearing. All right, in this example, you're seeing something that's within a span that's showing non-load bearing. That's an example of something that would not be carrying load down, okay? And again, we're thinking about things from here. Load has to be carried all the way down, all the way down into a bearing capacity within the soil, and that's dictated by where it is being built and other specifications such as frost depth and so forth. Again, not going to get into that, but that's the very general example of anything that's load, okay, has to be directed all the way down to the earth, all right, in very simple explanation. So although this is saying non-load bearing, this is actually going to be a load bearing wall here. Again, then because it's stacked above, where you remember that I-beam in the basement, okay, starting from here, anything stacked above that is most likely going to be load bearing. Anything within that is not going to be, because we have a span that can be carried up to a point. Okay, I don't want to try and lose you guys on any of this stuff. I want to make it as simple as possible. So in a general aspect, just going right back to it, anything that's running perpendicular to floor joists, ceiling joists, etc., is going to be load bearing most of the time, okay? Or anything that's stacked above your bearing beam, your main bearing beam, is going to also be load bearing. As you can see in this example, here's your bearing beam like we saw in the basement. Here are the columns, okay, within the basement supporting that beam. And then here's everything stacked above that beam. Like I said, this is actually inaccurate. That's going to be most likely load bearing. There's your floor joist running perpendicular. There's your floor joist running perpendicular. Here's your actual, this is like a ceiling joist or a collar that's running perpendicular. Okay, those are all the things that are being supported by those beams or other structures. Okay, now, real quick, the reason why most of the time we're trying to figure out if something's load bearing or not is because we want to remove it and we want to see if it's possible. Almost every single time, it is certainly possible to remove load-bearing components of a structure. You just have to support what you're removing. So if a wall, right, this entire wall is running all the way down the structure, that's supporting everything in line that's above it, holding it down. If you want to get rid of a portion of it or all of it, you have to pick up that load and spread it out to the outside again, right? To the exterior. In this case, you saw down in this basement would have been your stem wall, which is carried down to the footing. Everything has to be carried down to the footing, the bearing capacity in the soil, okay? So if that wall goes away, we have to put in a beam and posts on some level to pick up that bearing capacity. So you, again, would have to have a structural engineer come in and just determine what size the beam needs to be and what size those posts, which would come out to the outside and whatever it's landing on, and again, would carry down, for those posts would carry down all the way to some point below foundation to pick up on a footing to support it on the bearing soil, okay? So you have to have a structural engineer design the size and type of material that needs to be used. But that's what you would end up doing, is sizing up a beam and posts to pick up any sort of load that you've removed, any sort of support on the load that you've removed within the structure. All right, hopefully I didn't lose you on any of that stuff. I wanted to make this as short and sweet as possible. I know sometimes I get wordy with that, but I want to make sure that you guys understand the general aspects of how to determine if something is load or non-load bearing. And again, if you keep it simple and think anything that's running perpendicular to the floor joists, once you can determine where those joists are, is most likely going to be load bearing, okay? And in that aspect, understanding that gravity is pushing down the whole way, you have to keep it from falling. So how do you support the dead and live loads pushing down and pulling down onto the property? Because it's doing both. You've got gravity pulling down, you've got weight pushing down, okay? And the reason there's weight there is because gravity's pulling on that as well. But you have to try and hold that up based on the sizing of materials and types of materials that you're being used for this structure, okay? So if you're thinking about it that way, anything that you remove and then post again has to be carried down all the way into that bearing soil. So just because you put a beam in, people always talk, we'll just put a beam in. Right, but where are the posts going to go? And what's below that post? Because that post has to be carried down onto another bearing component or all the way down into the bearing soil, meaning footing, bearing on what's determined as proper bearing soil, okay? That's basically the most solid surface you can find at a certain depth, again, determined by location of where it's being built, to accept that reallocated load, and basically it's moving somewhere else from where it was originally because you're carrying it away from an opening, okay? If you do have questions from this video, please make sure that you leave them in the comments below. I can do some more videos if these are easy enough to follow. We can get more complicated if we need to. Just let me know in the comments also if you want to do more videos on this. We can go into real life scenarios. I'm going to try and touch on some of that. I do have other videos that talk about headers, how to frame up walls and so forth with those headers within them, which are just small beams picking up that same sort of load within a load wall. Go check those out. If you enjoyed the video, if it made sense, and you want more of them, hit that thumbs up on the way out. Please do that because it helps get the video and spread it out. And if you're not subscribed yet, please consider subscribing. Hit that subscribe button and the bell for notifications so you get more of these videos when I post them. I'm posting them just as fast as I can get them out. I've got all kinds of stuff going on. So I'm doing my best to get the educational videos out. I love doing them. Make sure you check out the podcast on here on YouTube and also on all audio platforms as well. Built by Bailey's podcast. Plenty of this information is being spread out there as well. Don't forget the merch, hoodies, hats, all kinds of stuff on the builtbybailey's.com website. It helps support the channel and everything else that we do. And there could be some great holiday gifts as well. All right, guys, that's it. Hopefully that made sense. If not, leave your questions. I'll try and answer them best I can. Until next time, keep building.